So this is section 1.2, essential functions. So I like the topic. It's a very important topic. I'm not a big fan of the book presentation, so this deviates a little bit. There's no homework out of the book related to this section, but I do have one ask of you. So what I'm going to do is I'm going to show graphs of what I consider the 9 essential functions for this course. Let me just add this as well. Page, what is it? I have to find it. 32. There's a nice chart that relays this information. They have a little bit more than what I'm going to present, but that's a nice reference if you want to see something in the textbook. So let's get to it. The first 3. Are going to be, excuse me, f of x equals x, f of x equals x squared, f of x equals x cubed. And those graphs look like this. We have a line. Oop, supposed to hit that. That's the origin. That's my parabola. And this is a so-called cubic. So a couple things, we don't put arrowheads on these. We understand these are not the endpoints, they continue on. So those are the first 3. Then the next 3, f of x equals absolute x. Oop. And again, we could use y equals, it's the same, it's still a function, but this looks like, sorry, that's supposed to hit the origin, sort of like a parabola. This is a sharp corner. This is a V, even though I just botched it. And one thing to notice about the first 4, the domains, the available x's for the first 4 is all real numbers. We can put any real number into any of these 4 functions. That's not the case with the next 2. F of x is root x. So we know that there's no negative values are available for this function. So the graph will start at the origin. It looks like that. It doesn't level off either. It just keeps going up, even though it kind of looks like it levels off. And then last for this page, sometimes 1 over x, sometimes referred to as the reciprocal function. And of course, you cannot put 0 in here. So this axis at x equals 0 is what we'll call a vertical asymptote later. So the reason that I'm doing this is because what I'm going to ask of you in regards to this section is that the 9 graphs that we present, that you know them just like that. You see one of these functions, this shape pops into your brain. Okay, that is critical information. You're probably familiar with these already, but I want you to know that you need to know what these look like. And the reason is, you might say, well, how many times am I going to see just x squared? And that's a good point. But what we're going to do later is we're going to learn how to make modifications to these. They're called transformations. So then we'll have now, working knowledge of what many different functions are going to look like. So we had to start here with sort of the vanilla versions, the no bells or whistles, so we can move on to do that. So the next 3, and again, one thing I want to point out, you might notice there's no numerical information here. It's not really necessary. The origin is kind of the anchor point of all of these. If you needed any points, you could throw numbers in there and get them, but you don't. It's more of a qualitative analysis rather than anything quantitative. That's a little bit different for the next three. So I'm going to label a few things here. 1, -1, pi, 2 pi, and this will be a half pi. This will be 3/2 pi. And this is going to be, and I'll even use y here. Could use f of x, but this will be our sine function. And this is one cycle, and I'm going to highlight that dot, highlight that dot, highlight that dot, and highlight that dot. So this is one cycle of a periodic function, so this wave repeats in both directions indefinitely. And this is critical. Trig is a big part of this course. It's a huge part of Calc 2. So we want to be comfortable with this as well as the cosine, which is the same shape, it's just shifted. So I'm going to label the axes with all the same values here. 1 and -1, pi, 2 pi, pi over 2, 3 pi over 2. Okay, this will be my cosine wave. So this is literally this shape just shifted half a pi that way. So this point goes here. This point here, here. In trig we call these the 5 key points. And another cycle of a periodic function. This repeats in both directions indefinitely as well. These are extremely useful throughout your whole calculus career. I'm going to put a 9th one down, which in all honesty is a little bit less commonly used than what we're going to do, but I think I should put it down. And that's the tangent function. And this is a little bit different. And again, we're not going to talk too formally yet. This will come later about what this dotted line is. What's called, these dotted lines are what we call vertical asymptotes. They're not part of the curve. We'll get to their kind of function later, but this is at -pi over 2, and this is at +pi over 2. And this looks a lot like that cubic function, sort of this snake kind of a thing. So these are vertical asymptotes. They're holes in the domain. You can't put these values in. It's a tangent. It's undefined there. And again, this is a periodic, so this is one cycle. So this would repeat indefinitely in both directions. Typically, when you graph a trig function, you just show one cycle. So the job that you have in regards to this section is that the 9 sketches here are committed to memory. And again, like I said, page 32 has the same, it has more actually. But so if you want to take a look at that, you know, for what it's worth. But again, there's no homework out of the text here. So know this. This will be useful in 1.3. So this is, in fact, this will be useful in 1.1. That's why I did this first, because when you see the video that wraps up 1.1, this was going to be useful. So I wanted this to be shown first. Okay. Check out we'll wrap up 1.1 in the next one, and then we'll Zoom, right? We'll Zoom on Wednesday. Okay. Have a good day. Well, watch the next video, then have a good day.